Today we're going over lesson 2.6 for geometry. This is on algebraic proof. I would say to reference this, there's a list of properties of real numbers in your key concepts packet. It's also listed on this lesson that you can use for the properties as your justification for these proofs. So the first problem we're going to do, it says to state the property that justifies each statement. So we're going to look at the statement first, and we're going to see the difference basically between what they're doing in the if part of the statement and what they're doing in the then part of the statement to get the answer. So we're going to put what property this is supposed to show. So if we look at the if part, it says if 4 plus negative 5 equals negative 1, then x plus 4 plus negative 5 equals x minus 1. So, as you can see there, the x has been added, and it's been added, so we're going to say this is the addition property. And to be specific from our list of properties of real numbers, it is the addition property of equality. So we're going to write that. For the next one, as you can see here, for the if part, they have if 5 equals y, and the then part, they've then put the y on the other side, and they've basically reversed it to be y equals 5. And that is showing, if you look on your properties of real numbers, that this is the symmetric property of equality. And this one, we are going to be proving this. So basically, we're going to think about how we're going to solve this, and we're going to write a justification for each step in the solving process. So on the next page here, I'm going to solve 2x minus 13 equals negative 5. And I'm going to use it as a two-column proof. So my given, my statements is what they call it. My statements are on the left side. And the reasons are on the right side, or the properties that we'll use are on the right side. So I'm going to go from 2x minus 13 equals negative 5 all the way down to x equals 4. And that's going to be my last step. So for the first statement, since they gave us this, we're going to put as our reason given. And then we're going to think of how are we going to get x by itself. Well, we're going to have to add 13. And since we're adding, this is going to be the addition property of equality. And that's going to give us 2x equals 8. The next step to solving would be divide by 2. And again, since we're dividing, that's going to be the division property of equality. And then finally, for our answer, since we've done 8 divided by 2, and we used division to do that, and now we're substituting that with 4, we're going to put as our final step substitution. And that would be my two-column proof. Now it's asking us to write a two-column proof to verify that each of these conjectures is true. So this is our first conjecture. So just like we just did with the last problem, we're going to solve this problem. So we need to get from if 5x plus 1 over 2 minus 8 equals 0 to then x equals 3. So we're basically solving, as I said. So we're going to do a two-step or a two-column proof with our statements on the left, our reasons on the right. whatever we're given, that's going to go for our given. So 5x plus 1 over 2 minus 8 equals 0. And we're going to solve this to eventually get, at the end, x equals 3. So our first step would be to add the 8, because our goal is to get the variable by itself. We're going to add the 8 to both sides. That's the addition property of equality. And then we get 5x plus 1 over 2 equals 8. Now we need to again cancel out what's on the side with the variable, so we need to cancel out the 2 by doing the opposite operation, which is in this case multiplication. So this is going to be the multiplication property of equality. And that gives us 5x plus 1 equals 16. Then we're going to need to subtract the 1, which is going to give us, well, we're subtracting, so we're going to use the subtraction property of equality. And that is ending up with 5x equals 15. And then our last step to get x equals 3 would be to divide. So that is going to be the division property of equality. So basically each operation that we do has its own property of equality. And then our last step for these types of proofs is going to be substitution. Now, this one, it gives us a scenario if the distance d moved by an object with initial velocity u and final velocity v in time t is given by d equals t times u plus v over 2, then v, or I'm sorry, that says u equals 2d over t minus v. So what I'm looking at here is they're basically going from d equals to u equals. So with our proof, to be able to prove this, we're going to need to show the steps from d equals to u equals. So I'm going to do a 2-column proof with my statements and reasons. We're starting with d equals t times u plus v over 2. So our goal here is to try and get u by itself because we want our equation to be equal to u. So the first thing I'm going to do is focus on the side with the u. I'm going to want to divide by t first because it's t times u plus v over 2. So if I'm going to divide by t, doing that on both sides, that's going to be, whoops, I'm going to put a line in between here because this was our given. Now we're dividing, so this is division property of equality. And we get d over t equals u plus v over 2. Again, focusing on the u side, so we're going to try to cancel out the 2 by multiplying. So now we have 2d over t equals u plus v. And we use the multiplication property here of equality. Now we just need to cancel out the v by subtracting. So we're going to subtract. And we get 2d over t minus v equals u. And we use the subtraction property of equality. Now, if we look back at our prove part, notice that the u is on the other side of the equal sign. Well, we have it as on the right side, so in order to switch it to the other side, we're going to need to use the symmetric property. So we're basically going to switch it to be u equals, and for the purposes of room here, I'm just going to switch it here. But I'm going to use my property to tell me that it's u equals 2d over t minus v, to say that I did the symmetric property because I put the u on the other side. And I have my answer. Now we're supposed to again write another 2-column proof to verify the conjecture. Here we're dealing with a little bit more geometry-based conjectures. So this is saying if angle B or angle A is congruent to angle B, and the measure of angle A equals 37, then the measure of angle B equals 37. So our given, we always start with statements and reasons. And our first statement is always the given. So in this case, angle A is congruent to angle B, and angle A equals 37. Okay, so that is our given. And we're eventually trying to get to angle B has to be equal to 37, which is the then part. So the measure of angle B equals 37. That's going to be our last step. So basically, you want to use the congruent statement, and I would replace the angle A, since you're given that it's 37, with 37. So 37 is equal to angle B. And since we replaced it, we also call that substitution. So we substituted. And now we have angle, or 37 equals angle B. Now, since it's on the other side, actually we don't even need this step, and we switched it to the, or we switched it on the side of the equal sign, we call that, again, symmetric property. And the last one, if CD is congruent to EF, then Y equals 8. Here's what we're given, that CD is 3Y minus 9 and that EF is 15. So we're going to set up our 2-column proof with what we're given. So we're given that CD is congruent to EF. And we're also given that CD equals 3Y minus 9. And EF equals 15. So the first thing we're going to do here is we're going to have to substitute. We're going to substitute 3Y minus 9 for CD and put that equal to EF because it said it was congruent. So we can use the substitution property for that. Next we're going to solve so that we can get y by itself, because eventually we're going to need to say that y is 8, and that's what we're proving. So we're basically solving this equation. So we need to add the 9. I get 24 equals 3y. Since I added the 9, that's going to be the addition property. And then I have to get that y by itself, so I'm going to divide by 3. Since I divided, that's your division property. And then our last step then, since we did 24 divided by 3, replaced it with 8, we're going to say substitution. And that concludes lesson 2.6 for geometry on algebraic proof.